Now that I've talked about what goes inside the connectivity pattern, the intra-data center networking component of the cloud service. Okay. One example is folded trees, a clutch network connected above a bunch of trees, for example. Okay. We're going to turn a little philosophical and take a look at what we have been talking about in the last 4 lectures, from 13 on IP and Internet design philosophy to 14 on TCP, distributed congestion control in particular, to 15 on P2P, that was last lecture, and today's lecture on cloud, okay, or data center. Across these 4 lectures, we were talking about 3 different kinds of networks. One is the backbone of the Internet. Okay. One is the network within the data center, and that's today, and one is using peer-to-peer as an overlay network to enable multicast. And it is a good time to pause a little bit and reflect upon these 3 different kinds of wireline networks design philosophy. There are many things we could compare and contrast, and I'll focus on a specific one, that is capacity versus connectivity. It's interesting to observe that in the Internet backbone, the standard practice to over-provision link capacity. Okay, to the point possible. At some point you can't, and then you have to run in fast time scale congestion control in TCP, or in slow time scale some kind of pricing. Okay, but the main idea is that you provision link capacities. You make them just the right numbers in the backbone of the Internet, and then you're going to run IP routing, say unicast routing, in a careful way to utilize these capacities. In contrast, in data center, you over-provision connectivity. Now, you just saw how many switches, small ones, that we needed, and how many links that we needed to connect these small switches in order to enable the ability to scale up by scaling out. And in P2P multicast, we see that we not only over-provision the connectivity, okay, make the connectivity pattern very rich and dense, we actually increase both number of paths possible for the chunks to flow, but also the number of sources. Each peer become a source of the content. Okay. And together with the number of paths going up, number of sources going up is going to enable an even richer kind of connectivity. And this is a progression from provisioning capacity carefully on running routing to going through a connectivity of provisioning, and eventually to provisioning the number and the location of the sources. And let that scale together with the number of paths or the number of trees that we're going to use across the chunks. So why the differences? Why the Internet backbone data center and peer-to-peer are designed following different philosophies? Well, there are 2 kinds of rationale. Number 1 is, as always in a commercial operation, cost drivers. What are the dominant cost component? For Internet providers, it often is digging the trenches for capital expenditure, okay, at least for wireline Internet. For data center builders and operators, because the distance is much shorter within a building, we're talking about from one floor to another instead of from west coast to east coast across continents. Okay. Digging trenches really reduces just to connecting the copper or fiber wires. And therefore, the cost of adding links is much lower than adding links in the backbone of the Internet. And this becomes even more extreme in the case of P2P, because there the concept of a link is logical. Remember, this is an overlay network. The underlay might be physical links. The overlay is actually a logical concept. Are you my neighbor? Are you my peer or not? If so, we have a link. And that link is a logical concept of peering relationship. So the cost of a link gets cheaper and cheaper at this point when it's conceptual, is actually very cheap. It still carries the cost of management overhead, but nonetheless much cheaper than digging trenches. The second rationale is our understanding and the flexibility of controlling the traffic. For the internet backbone, the traffic matrices, that is, from a source to the destination, usually at this hour, how much traffic do you expect end to end? That you can collect into a matrix called traffic matrices. Traffic matrices values for the internet backbone are very well documented and estimated. For data center, however, the traffic demand pattern is not as well understood. And for P2P, actually, we can even change the traffic matrix because we can redefine who are the sources and who are the destinations of a particular multicast tree. That is up to us to design. So because of the difference in cost drivers and the difference in traffic understanding control, we are led to this philosophical difference in provisioning capacity versus provisioning connectivity, even to the extreme case as we compare internet backbone with data center and P2P. So in summary, for today, we saw how can we scale up by scaling out through the idea of multi-stage switch network. Okay. We can go a lot more into the details of different variants of multi-stage switch interconnection network. We could also go into more detail of other dimensions of a data center operation. Part of that will be covered in advanced material. Economy of scale is what drives data center, and therefore it is so important to be able to scale up. And even when we are bottlenecked by per node capability, we can scale out the topology. And that gives us a wonderful example of provisioning connectivity. Connectivity richly provisioned becomes a very powerful resource. And we have to be carefully designing and leveraging that. And now we're going to move on to another dominant technology trend, which is video. Last two lectures we talked about peer-to-peer and cloud and data center, respectively, for massive amount of content distribution. A lot of those content are video content, and we're going to see the interaction across functional modules, the layers in a network protocol stack, as we go into next lecture on video distribution.